Welcome back to our Flownex online training. We are taking on our 11th session, and in this one we'll look at Flownex's Excel enhancement. Now this is probably every engineer's best friend, so it will open up new horizons to you in getting your way with our thermal fluid software. The component has its own special place in our library, so you can drag it from here onto your canvas and double click to open up the very familiar Excel interface. I will use this Excel component to determine the heat load on my generator based on a specified plant load. I have the performance curve from the manufacturer in an external Excel file that shows the curve of heat load versus plant load. And I already created a trend line to characterize the chart with a correlation. So back to Flownex. The left hand side of the Excel component is my interface between the two software. So all communication between Excel and Flownex is set up in this area. For our case, we'll require one user specified input value to Excel, which will be the specified plant load. And then Excel needs to calculate one output value to send to Flownex, which will be the generator heat load for both our cooling sections. To create a user specified input, I need to edit my inputs and say add. Give a description for bookkeeping and allocate the cell in which I will specify the value. Let's make it B2 and remind myself of what value this is. Excel needs to calculate the heat load for each side. So I can type in my correlation and divide the total heat load by 2. The easiest way of linking these values between Flownex and Excel is to simply drag and drop the value into the cell it needs to communicate with, and then state whether it should be an input or output. And again, give a description. Another way of linking these values would be to use the data transfer link, but I like the drag and drop function better. With the communication now set up, I need to test my work with a value in the interface section and confirm its functioning. And finally, I need to tell Excel when it needs to perform. And for this, I can specify before Flownex, parallel to Flownex, or after Flownex. In our case, we first want Excel to calculate the heat load and then send it to Flownex so that Flownex can solve the rest of the system using that value. So here it will be before steady state. If your Excel component isn't working, it's probably because you forgot to specify anything here. I can drag my input value onto my canvas to make it more visible and then solve. 100% gives me 70 kilowatt per section, causing respective heat exchanger temperatures of 103 and 49, and a water outlet temperature similar to that of your geyser. Change to 80% load, and we get again 50 kilowatts per section with our initial heat exchanger temperatures. And that's how we integrate Excel into Flownex. And obviously, there are endless calculations and commands that I can perform in the same way. All this to empower you with full customization of all correlations and commands in our default library components. And if you are a C coding guru, you can create the same and even more powerful magic with the script component. But that's something for another day. In our next session, we'll color this thing crazy using our visualization components to create an HMI or system SCADA and implement some operator tools. But until then, keep on training those Flownex skills.